This is one of a series of videos in which you will be introduced to use StatCrunch in order to compute probabilities and or expectations and or deviations in models of probability, introduced in both chapters 6 and 7. So first, let me go back to our whiteboard, and in our whiteboard introduce you to the models that we're going to build and talk about. And in chapter 6, as our earlier video shows, we are introducing discrete models of probabilities for random quantitative variables. Variables that are random, in other words, are subject to uncertainty. We don't know what values they will assume, but we do know that these values are quantitative, not categorical. And in chapter 6, the models that are covered are 1, the custom model. So we will define what a custom model is. Then we will define what counting models are. And then we will talk about something called the discrete uniform model. And when we talk about counting models, we'll actually talk about the geometric number of trials model, the binomial number of successes model, and the Poisson number of successes model. So we usually will use the letter X to denote a quantitative random variable. And in this particular video, we will actually look at the custom model. So what is a custom model? A custom model of probability when we know the values of X, when those are given to us, or we know exactly what possibilities there are. So this is a list of all outcomes. And these outcomes are called distinct outcomes because they are identified individually without any dependence or any reliance on anything else other than it. And you also know the probabilities of X. So we also are aware of the entire probability space, the list of respective probabilities for each of those values. So that is what a custom probability model is and what it looks like. So allow me to introduce something that you might see in Lab 6. A company rents a refrigerator for their restaurant business. This refrigerator may need one service per year, 2 services per year, or 3 services per year. No more. And each of these services, based on the history that has been generated from past years by the provider of the refrigerator, they know sort of the service history of past models and past refrigerators that they have leased to restaurants. The one service per year, which can occur with probability of, say, 70%. Two services per year, which can occur with probability of 0.15%. Three services a year, which can occur with probability of 10%. Let me change this to 35. So my first task will be to build the custom probability model. And my second task will be to calculate the mean number of services per year. That would be also known as the expected number of services per year, where X is the number of services per year. And thirdly, calculate the standard deviation of number of services per year. A number that is just like in chapter 3, standard deviation, whose purpose it is to measure how things can be different than expected. So sometimes a refrigerator might need more services than expected, sometimes fewer services than expected. Okay. So again, we have chapter 6 is about discrete probability models. And this particular example is about something called a custom model of probability. And the kinds of questions that you will get when you have a model built are questions of this kind: build the model of probability, and then calculate the mean and the standard deviation. So to build a model, I'm going to simply build a table. So the answer to question number 1 here is right down there. X is going to be the variables representation of the number of services per year, and P is going to be the probability for each one of these values. So X can be 3 or 2 or 1. And in this case, 3 happens with a probability of 0.1. 2 happens with a probability of 0.15. And 1 happens with a probability of 0.35. And then we apply the notion or concept of what a probability model is. And a probability model is a complete story. And that's the key to understanding models of probability. A probability model is a complete story. So it has to tell you 100% of what could occur, not just partial. A complete story about a variable, in this case, an event, subject to uncertainty. An event subject to uncertainty, as we explained in chapter 5 when we were exploring the rules of probability, is an event whereby we don't know what will happen, but we can still catalog what might happen and how often these occurrences might occur. And we employ the law of large numbers and randomness, the principle of randomness, to actually calculate probabilities through the 9 rules of probability from chapter 5. And so now we have the issue here being that we're talking about a complete story. And if you look at these probabilities that I've just listed here, they don't really tell a complete story because they only tell us what's happening 60% of the time. So there's something else, something's missing here. What's missing is that there are some refrigerators that need no service whatsoever. No service would be the complement event to needing a service. And because we can't have more than 3 services per year, none were described in the story of this model, then it must be the case that the probability of no services is the complement probability of 40%. And so notice that now the story is complete because the sum of all the probabilities equals 1.0. Okay. So I have completed task number 1. I've completed the task of building the model of probability. Okay, so that was part 1 of my problem here. Part 2 is calculating the expected value and calculating the standard deviation. And the way we do this in models of probability is with the following formulas. So to calculate the expected value of a custom model random variable, what we have to do is take the sum of the product of the values of each possible value times its respective probabilities. It's essentially a mean. It's referred to as a population mean. And we usually use a Greek letter to denote the population mean. We usually use the Greek letter for M or mu. And we usually also call this the expectation or the expected value of X. So an expectation is an average. It's a middle value where we use, instead of repetitions of something that is experimental or that is observed, we use the what we know in mathematics as a weighted average of the values. And the weights are the probabilities. Likewise, the standard deviation of a random variable is the square root of the variance of a random variable. And in a random variable, that is also known as the population standard deviation, which is the square root of the population variance. We usually use a Greek letter to denote that. It's a Greek letter S in small case, and that's known as the standard deviation of the random variable X, and that is the square root of the weighted average of the deviations from the mean. Each value differs from the expected value. Square deviations from the mean, in which the weights are, again, the probabilities. Okay. So the formula for this is the square root of the sum of how each value differs from the expected value squared times the probabilities. If we were using the StatCrunch to do the math for these calculations, we would proceed by creating a column called X, such as this one, a column called P, and then we could use data compute expressions, and we would type the expressions that I have drawn out here, that I have detailed here in purple, to calculate the mean and the standard deviation. So that's one approach at using StatCrunch to do the math. I will exhibit this approach in a moment. The other approach is we could also use stat calculators custom. So there are two ways to actually do the math on what I will highlight in orange now. To calculate the mean and to calculate the standard deviation, what we're going to do is look at the following command, stat in StatCrunch, then calculators, and then pick the calculator called the custom calculator, and follow the directions that the custom calculator requires. So let's move to another screen. And in this case, I am moving to a screen with my lab and mastering. And in this My Lab and Mastering screen, I'm going to choose StatCrunch and open StatCrunch blank and put in the model. And after I put the model in, we will do the command to calculate both the mean and the standard deviation of a custom model very quickly. Sometimes when you try to log into My Lab and Mastering, you might get an error message. So all you have to do is go back to the Open My Lab and Mastering and control click or command click, and it should then create a stronger acceptance of your what's called single source originator signing from Canvas to your Pearson, and it should go right through. I'm going to open StatCrunch. You might encounter the same problem upon opening StatCrunch. I'm opening StatCrunch in a separate window, so I do control click or command click, and StatCrunch should open. And if it does not open, just again go close that tab and resubmit the single source origination login, and that should basically allow the opening of the software. Once we're there, it takes seconds for the math to occur. So as we were describing earlier in the whiteboard, we're going to create a column of values of X and respective probabilities, and then we're going to use stat calculators custom. So let's go into our StatCrunch. I'm going to change var1 to X. I'm going to change var2 to P. I'm going to put here 0, 1, 2, 3 or 3, 2, 1, 0. It doesn't really matter in what order you place them. That is a count of how many refrigeration services happen. And as I recall, this is 0.1, 0.15, 0.35, and 0.4. And now I'm going to click on Stat, Calculators. And the custom calculator is the only one that's not alphabetically ordered. It's the last one on the list. So I click on Customs. I tell the software that the values are in X and that the weights are in P. And I compute. And I get the expectation or mean at 0.95 and the standard deviation at 0.973. And I'm done. That's how simple it is to actually do the expectations and the standard deviations using StatCrunch. The longer road to calculating the mean and the standard deviation involve using data compute. I'm going to use this command, multiple expressions. And what I'm going to do with multiple expressions is compute something called E for expected value and SD for standard deviation. And the expressions that I'm going to put here are going to be the formulas from our whiteboard. So I'm going to call my formulas. Take the square root of the sum of this square root of the sum of this mess. And I'm going to, rather than copy them because they have brackets, I just noticed, I'm going to type them out. So I'm going to take the square root, open parenthesis of the sum, open another parenthesis, and a second one, and I'm going to take capital X minus E. E is the expectation here. And I'm going to close that in square, and then I'm going to multiply that by P and close the second parenthetical. And then I'm going to close the third parenthetical. Because I opened a total of 3, I have to close a total of 3. And over here, I'm just going to take the sum of X times P. And that'll calculate the expectation first and then the deviation. So once I type the two formulas as I have described them in the whiteboard, mind you, you might want to pause this video and take a photo with your phone or jot down these formulas and how they relate to the column labels of X and P. And upon building these, you just compute. Click on Compute. And notice that we get a mean and a standard deviation that are identical to the mean and standard deviation that StatCrunch computes much more quickly through the command called stat calculators custom. And your selection of X for values and P for weights. I hope this video was very useful at computing what are known as custom models of probability, in which the problems are given to you in full detailed description of each possible value of X and the respective probability. Occasionally, some of the problems in your lab and in your quiz and in your exam 3 will not have all the values because they'll be missing 0, for example. And the way you know that they're missing an ingredient is that the probabilities that they give you do not add up to 1.0, do not add up to the whole story, the complete story. So now, once you know how much of the story you know, the complement value has to be the rest of the story, whatever adds up to 1.0 probability. So what do we now know about refrigerators that are rented by restaurants from this company? We know that we should expect about 1 service per year. That's the expectation, slightly less than 1 service per year, give or take another service per year. In other words, I'm going to think of this 0.95 as a 1, and I'm going to think of this 0.97 as another 1. And then I'm going to say in the storyline, I can expect about 1 service a year plus or minus 1 service per year. And when I rent this refrigerator. And that's how we do the math on a custom model. Thank you for watching this video, and I'm going to be also demonstrating how to use the discrete uniform model as well as the other counting models in other videos to come in this series of probability models, discrete probability models. I hope that this video helps you complete with success your questions in Lab 6 and Quiz 6. Bye-bye.